Let's look at another example. This time we have y equals cotangent of 2x minus pi over 4. Once again, to get our transformations understood, we're going to rewrite this function as cotangent of, and then we're going to factor out the coefficient for x, which is that 2. That would leave us with 2 times x minus pi over 8. And again, you can double check that by distributing the 2 back in. We'd get 2x minus 2 times pi over 8 is pi over 4. So that's all working out well. All right, so our period for this function is going to be pi, the original period of cotangent, divided by b, which is 2. Okay, so pi over 2 is good for that. And then our c value, of course, is pi over 8, which means we're going to shift to the right by that far. Now, before we get to this full graph of this transformed cotangent function, it's always a really good idea to have the parent function in mind. So let's recall what the parent function for cotangent would be and sketch it up here. You might recall that cotangent is similar to tangent, but it's shifted over a little bit. It actually has a vertical asymptote right on the y-axis. And then, since the period of cotangent is pi, just like tangent, the next asymptote would occur over at pi. And then in halfway between the period, or halfway between the asymptotes, you'll have an x-intercept. But then, unlike tangent, this one goes from left to right, high to low. So it has a point up and left, and then down and right. And if you connect those with a curve, you'll get the shape of cotangent, which is kind of like the reverse of tangent. It goes high to the left, down low to the right. Of course, you can repeat this period as many times as you want. So at negative pi, we'd have another vertical asymptote and another curve that would look just the same there. All right, so this parent picture will help us as we gauge our new one. Let's go ahead and draw some axes for our final graph here. And since one full period on the parent function was the distance between the asymptotes, which was from 0 to pi or from negative pi to 0, both the same, those were a distance of pi. Our new period is pi over 2, so that means my first asymptote is not at pi, but it's at pi over 2. So I'm going to label that and go ahead and draw that vertical asymptote in. Of course, also on the y-axis, we have a vertical asymptote. It's kind of hard to see, but I'll put one on top there. And then halfway between the asymptotes, we have an x-intercept. I'll continue this even one more period to the left, which would take us all the way out to negative pi over 2. Another x-intercept halfway between those vertical asymptotes. And so you can tell then we're seeing the same pattern here. Now let's not forget that we have to shift this graph to the right by pi over 8. Alright, so it's easiest to shift things left and right when you just have the x-axis labeled conveniently so that you're shifting, 1 or 2 tick marks on it or something like that. So let's make sure we have that labeled correctly, and this should be no issue. Before we go ahead and label, let me add some markings that will indicate the place of our high and low values. So as you recall, the parent function has a high value to the left, a low value to the right. Of course, those would be just 1 or negative 1 at this point because the amplitude has not changed. So I'm going to put those points on there also, which will be shifting to the right by pi over 8. But it's nice to have them on there before we do the shifting. Alright, so everything we see on here, all 3 points in each period between the asymptotes, and all the asymptotes need to shift to the right by pi over 8, but as we've conveniently labeled this axis, that's now, hopefully, let's find out. Remember, this is 0 to pi over 2 between our first set of asymptotes, which means halfway between that would be pi over 4, and halfway between 0 and that is pi over 8. So indeed, all the little tick marks we now have on the x-axis represent the distance of pi over 8. So I just need to shift everything to the right that far. I'll start from the left period I've drawn over here, shift this high point to the right, 1 tick mark, next one to the right, 1 tick mark, 1 tick mark. Everything's going to the right, even the asymptote. So that first asymptote I'll drag over there. Second one is going to be dragged over here. Same thing with the third one. I'm going to add another marking there for that. Everything's moving pi over 8 mark to the right, including all these points. Alright, now it's of course kind of hard to see sometimes with this, but it's better than trying to shift the entire graph. So all we've moved is the points and the asymptotes. If I go ahead and connect the new points in their spots, I get the following function. Remember, it starts high on left, low on the right for cotangent. So we're just following that pattern and staying within the new boundary of our new asymptotes, which are all of the right-sided asymptotes in each pair that you see there. And so what we're looking at now is the graph of cotangent in the way it was specified above with all of these transformations.